Okay, so in this video I want to answer a problem that was posted online and hopefully give a video solution. So here's my solution. We want to find the integral of the function sine cubed x dx, all divided by cos to the 4x plus 3 cos squared x plus 1 times the inverse tan function of sec x plus cos x. Now this looks rather nasty, so the first thing I'll do is I'll write this a little bit differently, and you'll see why by the end of this video, while I've done it this way. So this is sine cubed x dx, all divided by, now here's what I'll do, I'll pull out the cos squared x. So I'll write cos squared x, so I factor this outside of the bracket, and instead I'm going to write cos squared x plus 3 plus 1 over cos squared x, and 1 over cos squared x is sec squared x, so that's sec squared x, multiplied by the inverse tan of sec x plus cos x. Okay, so now it's here where I do my substitution. So here's where my substitution goes. So now I'm going to let u be equal to sec x plus cos x. Now if I differentiate, then this becomes du equals sec x tan x, because sec x tan x is the derivative of sec x, minus sine x, because the derivative of cos is minus sine. So it's that dx. Now what I'll do is I'll write sec and tan in terms of sine and cos, so you can hopefully see that this simplifies rather nicely. Okay, so this becomes du equals, well, sec x is 1 over cos x, and tan x is sine x over cos x, so that term just becomes sine x divided by cos squared x, and now I've got a minus sine x dx. Now I'm going to factor out sine, so if I take out a factor of sine, I'm left with sine x times 1 over cos squared x minus 1 dx. Now hopefully you might start to see what I'm trying to do here. If I simplify this term inside the parentheses, this becomes sine x times 1 minus cos squared x all over cos squared x dx. And you know from the Pythagorean identity that sine squared x plus cos squared x is 1, so therefore 1 minus cos squared x becomes sine squared x. And sine squared x times sine x is sine cubed x. So this whole thing becomes sine cubed x over cos squared x dx. So you might notice that this is in a very nice form, very similar to the way I wrote this integrand in the beginning. But there's one more thing that I want to do. And you remember that I made the substitution u equals sec x plus cos x. Now here's where the trick is. What I'm going to do now is I'm going to square u. So if I square u, I get u squared equals sec squared x plus 2 times sec x cos x plus cos squared x. Okay. Now notice that sec x is 1 over cos x, and now we've got that times cos x, and sec x times cos x is just 1. So this becomes, so u squared is then sec squared x plus 2 plus cos squared x. And you'll notice that this is very, very similar to what I wrote in the denominator of this integrand, except this says cos squared x plus 3 plus sec squared x. So in fact, this whole term right here is just u squared plus 1, because if I take what I've just got here by squaring u, and I add 1 to it, then I get what's in the brackets. Okay, so putting it all together, what do I get? Okay, so let's go back to our original integrand. I had sine cubed x dx over cos squared x, and we know that that now simplifies to du thanks to the substitution I just made. Okay, now in the brackets I had something that looked like u squared, and if I added 1 to it, it became sec squared x plus 3 plus cos squared x, which is what I wanted, which is what was in the brackets. So now this is just u squared plus 1. And I've also got my inverse tan of u. Now hopefully if I write this in a different form, it should now be much clearer what to do with this. If I now write 1 over u squared plus 1 du. Let's put that in brackets, and then divide by inverse tan of u. You might notice that this isn't a very useful form, and if you can't remember what to do at this stage, then I'll write it. Well, recall that if I've got something in this form, f prime of x over fx, or f of x, dx, and then I integrate, then it'll be of the form log of f of x, where by log I mean natural log, plus c, where c is some arbitrary constant. So what that means is, when I integrate this thing, I know that the derivative of tan, or arctan, is 1 over 1 plus x squared, or 1 over 1 plus u squared in this case. So I've got a function and its derivative on the top of it, so therefore if I integrate this thing, I'll end up with log of arctan of u. So what do I get? Well, I end up getting the natural log of the inverse tangent of u, plus some arbitrary constant of integration c. So what is u? Well, I made the substitution u equals sec x plus cos x. So this in fact becomes log of the inverse tangent of sec x plus cos x plus c.